Okay, we talked about graphing. Okay. We talked about solving linear systems by graphing. Now we want to look at how to solve linear systems by using the substitution method. Now this is section 8.2, and we will mainly be talking about how to solve the systems using substitution. Now the idea is, graphing has some serious drawbacks. Now the idea is, if the point of intersection where the two lines meet turns out to be fractions where your x and y coordinate are both fractions, then how would you find that point of intersection if you cannot find the exact value of it? And that's why we introduce the substitution methods to help us out of those sort of situations. Now this method is particularly useful where one equation is already solved or can be solved easily for one variable. Now what do I mean by that? Let's look at this example here. Let's say we have this example. We have two equations, x plus 3y equals negative 28 and y equals negative 5x. Now as you can see, our second equation is already solved for y. So when we are substituting, what we will do is we will take this y equals negative 5x, and since y is already solved for x, we will go ahead and substitute this value into our first equation for y, and we will then solve our problems. In your substitution method, you are basically substituting one equation into the other equation. So what I will do is I have my x plus 3y. Now instead of writing y here, I am going to take what y is solved for, which is negative 5x, and substitute that in here, and that will give me this first equation, which is now only in terms of x. As you can see, you have x plus 3 times the quantity negative 5x equals negative 28. So now since my whole equation is in terms of x, I can go ahead and find the value for x. So let's go ahead and solve this. This will give me x minus 15x equals negative 28, which will give me negative 14x. Now we want to get x by itself, so I divide both sides by negative 14, and that will give me x equals positive 2. And you can see how simple and easy that turns out to be once we substitute our y with this negative 5x here. Now that you have your x value, you can find your y by substituting it, by taking your x value, and substituting it into any one of these two equations that we started out with. So we ended up with x equals 2. Now let's look at so let's say we use y equals negative 5x, and we can now substitute our x with 2, and you will see that y value is now negative 10. Okay. Once we find the solution, now what we want to do is check our answers and make sure that it works for both our equations, just like we did when we were graphing these. So I will take my first equation, and your first equation is x plus 3y equals negative 28. So let's see if we end up with a true statement. Your x was 2, your y is negative 10. That will give you 2 minus 30, and you will see that we end up with a true statement. Okay, and we'll do the same thing with our other equation, which is y equals negative 5x, y is negative 10. x is positive 2, and you end up with negative 10 on both sides. So again, we have a true statement. And now we can say that the ordered pair 2, negative 10 satisfies both our equations. So your solution set is going to be the ordered pair 2, negative 10. Okay, so this is how your substitution method will work. We substituted one equation into the other, solved for one of the variables, and then substituted that answer back into the second equation to find our second variable. Now let's go ahead and take a look at another example here. In this example, your system of equations is 4x plus 3y equals negative 5, and x equals y minus 3. Now in this example, you can see that our second equation is solved for x. You have x by itself on one side and everything else on the other. So in our first equation, we'll go ahead and substitute the value of x with y minus 3 and solve our equation just like we did earlier. So you have 4, substitute your x with y minus 3 plus 3y equals negative 5. And now you can see this equation is all in terms of y. We got rid of the x variable here. So when you solve this, you end up with 4y minus 12 plus 3y equals negative 5. Combine your like terms, which will give you 7y minus 12 equals negative 5. We'll take our 12 over to the other side, and that gives you 7y equals 7. Now get y by itself, take your 7 over to the other side, and you will see that we end up with y equals 1. Now again, we'll go ahead and substitute the value of y into one of these equations here and find the value for x. So we'll go ahead and use the second equation, where you have x equals y minus 3. If y equals 1, then x will equal negative 2. Okay? Now, let's go ahead and check our solutions here. So we'll go ahead and substitute in one of our equations. And our first equation was 4x plus 3y equals negative 5. So your x value is negative 2. Your y value is a positive 1. And we end up with negative 8 plus 3 equals negative 5. And as you can see, we end up with a true statement again. Do the same thing for our second equation, which was x equals y minus 3. And let's see if we end up with a true statement again. Okay, so since both our equations verify that the ordered pair negative 2, 1 satisfies them, we can go ahead and say that the solution set for this system is going to be the ordered pair negative 2 and positive 1. Alright, now that we have looked at these two examples, let's just do a quick recap of the steps involved in solving a system of linear equations by substitution. Okay, your first step will be to solve one equation for either of the two variables. If one of the variables has the coefficient of 1 or negative 1, choose that variable, since the substitution method is usually easier this way. So that will be your first step to solve one equation for any one of the two variables. Your second step will be to substitute for that variable in the other equation, and the result should be an equation with just one variable. So once you solve your equation in the first step, in the second step you'll go ahead and substitute that into the other equation. Okay? Then your step 3 will of course be to solve the equation that you just created in step 2. And let's see, the next thing that you will do after that will be to substitute the result from step 3 into the equation from step 1, which will be the two original equations, and find the value of the other variable. And then of course your last step always is going to be to check your solution in both of the original equations and then write the solution set. So pretty much just the exact same thing that we did. You just have to keep in mind of how to go about doing this. So let's look at one more example, and in this example you will see that our equation is not already solved for one of the variables. So your first step is to solve the equation for one of the either two variables. Now, as it said, look for the one that has the coefficient of 1 or -1, since that would be the easier one to work with. Now you can see your coefficient on the first equation for x and y is a 5 and a 2. On your second equation, the coefficients are 2 and -1. So since in our second equation the y has a coefficient of -1, we will solve our second equation for y. So the first thing we do here is take our 2x minus y equals -6, move your 2x over to the other side, leaves you with -y equals -2x minus 6. Now we still want a positive y and not a -1, so we need to get rid of this negative here. We divide everything by a -1, which will give you y equals a positive 2x plus 6. Alright, now that we have solved our second equation for y, we can go ahead and take this value and substitute it into our first equation here. So you have 5x plus 2y, but instead of y we will go ahead and plug in or substitute 2x plus 6, and that will give us -15. Now again, you will see our second equation now, or our first equation now, is all in terms of x variables. So let's go ahead and find the value for x. Right, combine your like terms, and we can move our 12 over to the other side, which will give us 9x equals -27. Get x by itself, so divide 9, and you end up with x equals -3. Now, since we have our x value, we can go ahead and find our y value, and again go ahead and substitute your x in any one of these two original equations that we had. So let's say we go ahead and use the second equation to find our y value. Now what we can do is, since we already solved our second equation in terms of y here, we'll use this form to find the y value. So you have y equals 2x plus 6. We said x was -3. So let's see what answer we come up with. And you end up with y equal 0. Again, go ahead and check your answers to see if this solution works for both the equations. And your first equation was 5x plus 2y equals -15. Your x value was -3, y is 0, And let's see, you end up with negative 15. This term here, of course, becomes 0. And you can see we end up with a true statement for our first equation. We'll do the same thing for our second equation. Your second equation was 2x minus y equals negative 6. Substitute x with negative 3, y with a 0. And again, we end up with a true statement here. And now we can conclude that since the ordered pair negative 3, 0 satisfies both equations, it will be our solution set. Alright, and there you have it.